We are working through question 4 and part A, in which we're asked to solve 1 minus cos of x on 2 equals cos of x on 2 for x is an element of negative 2 pi to pi. The first thing that I'm going to do is simply rearrange this so I have cos on only one side. So I'm going to be plussing cos of x on 2 to both sides. So I'm plussing cos on x on 2 to both sides, and by doing that this is going to go away, which means I'm going to be left with 1 on this side is equal to, and because I'm plussing these together, it's simply going to be 2 cos of x on 2. And now I want cos by itself, so I can simply divide both of these sides by 2, which will leave me with cos of x on 2 is equal to 1 over 2. So what I simply did there is divide that side by 2, and I divided that side by 2, and now I am here. I also need to re-express my domain, because as you can see here I have x over 2. So I'm simply going to express my working domain. So it's going to be x over 2 is an element of, and I'm simply going to divide this by 2, which is going to leave me with negative pi, and I'm going to divide this by 2 as well, which will leave me with pi on 2. Having now done that, what I prefer to do in this situation, there are lots of different ways to do it, but I would just draw for myself a little unit circle like so, and let me just move this up a little bit. Let me just put it here. And now what I can say is, well, I'm dealing with, and let's keep it as black, shall we? What I'm dealing with here is cos x on 2 is equal to a half. So I would mark on, because I'm dealing with cos, I'm looking at my x-axis, and just put in a half. So that right there is going to be a half. And now what I'm doing is finding the angles which will get me this exact value. So that means it's going to be this one, and it's going to be this one right here. But before we start drawing in what our angles are going to be, we're going to have to consider our domain. And as you can see here, it's negative pi to pi on 2. Again, you should have a really good understanding of what this means, but let's just take it slowly and really just spell it out. If I was to put this on a number line, so if I just draw myself a number line, let's say this is 0, let's go back to negative pi, and let's go forward to pi on 2. So right here, actually, let's make that a bit closer, shall we? Pi on 2 like that. So I can only consider values which are from here to here, which on my unit circle would correspond to this region right here, from here to here. And I can also only consider from 0 to pi, negative pi. So that would correspond to 0 to negative pi. So only within these regions can I have answers. Well, having now done that, it's pretty clear what I'm going to be dealing with. It's going to be this region right here, so here to here, and obviously that is going to be pi on 3, and also here to here, and that's simply going to be negative pi on 3. So this is all based on knowing that when I have an exact value of a half and I'm dealing with cos, my reference angle is pi on 3, and then from there looking at my unit circle and considering my domain is pretty straightforward what I'm going to be doing. So now I can come here and I can say, well, x on 2 is going to be equal to pi on 3, and actually let me put my negative one first, negative pi on 3 and pi on 3. But remember, our answer has to be just x. So what I'm now going to do is I'm going to multiply this by 2 and multiply this by 2 and multiply this by 2. And by doing that, these will go away. And I'm just going to be left with negative 2 pi on 3 and 2 pi on 3. And that right there, everyone, would be my answer. So let's highlight that. And perfect. Again, there are different ways to do this, but this is my preferred way. Let's now look at the examination report and see how people fared with this question. So let's come over here and let's have a bit of a look. Ooh, let's come over here. So as you can see, those are our answers. And let me just bring this to the front, bring to front. Okay, so as you can see, 48% of the state got the full 2 marks for this. This is how they approached it, the same way we did, negative 2 pi on 3, 2 pi on 3. Most students were able to rearrange to form the correct expression. So what that means is getting to this stage right here, realizing that you had to plus the cos and then divide the 2 and such. Some students did not identify the correct reference angle, and I think that's where many people, if you're watching this, may struggle with. I immediately knew that cos of a half is going to be pi on 3. That's just something that I believe you just need to memorize. Many students did not account for the restricted domain, so also considering the working domain is really important as well. All right, so let's now move on to part B, and you're going to see that these are intimately related, A and B, with each other. So here it is. It says the function f, here is our domain, f of x is equal to cos of pi on 2 is shown on the axes below. Let g, for the same domain, so g of x is going to be equal to 1 minus f of x. So let's just write down what that's going to be. It's going to be 1 minus f of x is simply this, so cos of x on 2. What we need to do is sketch the graph of g on the axis above, label all the points. So get your highlighter out and just label the key pieces of information. Label all the points of intersection of the graphs, so intersections, and the endpoints of g with their coordinates. Okay, so that's what we need to do. What you also need to take a note of is the fact, if we just come up here for a moment and let's just scroll out. As you can see here, I have cos of pi on 2, and that's simply this over here. And we're also dealing with 1 minus cos of x on 2. So if I was just to highlight this for a moment, that is simply over on this side right there. So why is that important? And why is it very important that you're just aware of what you've done previously? Don't just kind of wipe the blank, don't just simply start fresh. You always want to be considering if there's any useful information in the previous question that you can utilize. And it's going to be very useful because when we're finding the intersection points, what you do is you set two things equal to each other and then solve for x. And we've already done that. These are going to be our intersection points. But let's not get ahead of ourselves. Let's just begin by doing what we know we can do. And that is we're sketching g of x. And we know that what we're going to be doing is we have a negative in front of our f of x, which means we're going to have a reflection across our x-axis. So let's just kind of mark in all those points. So this point will now be down here, and this point will now be up here. Of course, this point is going to stay the same. This point is going to stay the same. Then we have this 1, which is going to be a translation 1 unit up in the y direction. So I'm just going to simply move this one up. And I'm going to move this one up. I'm going to move this one up. And I'm going to move this one up as well. So now with all those points, whoops, did I just rub out the wrong one? I did. With all those points, we just need to connect them. Now, let me do the first one. So it's going to go here all the way to here. And as you see here, I'm going to get something like this, and I'm going to cross this point right there. So let's just mark in where my intersection point is going to be occurring. My intersection point on that side is going to be occurring at negative 2 pi on 3, knowing that the way I solve it is simply setting my two functions equal to each other and solving for x. We've already done that. You'd be crazy to do it again. So that means negative 2 pi on 3. Well, thankfully, things are nicely already split up into 3's here. So this is going to be negative pi on 3. This is going to be negative 2 pi on 3. And this is negative 3 pi over 3. Negative 3 pi over 3, which is just negative pi. So that means my intersection point is going to be occurring right here. And then so too on this side, this is going to be pi on 3. This is going to be 2 pi on 3. My intersection point is going to be occurring right here. So now I can continue to draw this in, and you know, it's really important that you do this nice and neatly. I'm doing this electronically, which is just very difficult, and I'm using a tablet. I just can't do it. It's just very tricky. So, all right, do what I say and not what I do. Your one has to be nice and neat. It cannot look like this. If you drew it like this, you probably would lose marks. They really want it to look nice. And it has to have the nice curves. It has to look flat at certain parts. Really show nicely. All right, that's pretty bad, but as good as I can do. All right, we also need to mark in what these points are. So we know that it's going to be negative 2 pi on 3 as my x. And what is my y going to be? Well, I simply just need to sub that into my f of x. So if I was to do that, to find what my y is, it's just going to be cos of 2 pi on 3 over 2. So just to really spell out what I'm doing here, to find my y value, what I'm doing is I'm taking my f and I'm subbing in negative 2 pi on 3. And you know, it would probably just be easier just to put 2 pi on 3 and not worry about the negative. So let's just deal with this instead. Negative 2 pi on 3, because I know it's going to be the same. So once I'm here, and I've already forgotten the negative there, it's going to be simply cos of this is going to be 2 pi on 6, which is the same as cos of pi on 3. And I know cos of pi on 3 is simply a half. So that means this right here is going to be a half. And over on this side, it's going to be 2 pi on 3 and a half again. So those are going to be my intersection points. And we also need to label the end points. This point right here is going to be negative 2 pi and 2. And my other endpoint here, so let's make sure that we do not confuse them. Let me just move this over here a bit. And that did not work at all. Let me try that again. Let me use the, let me just move this over here like that. Still didn't work. Wow. I'm just doing a great job here. Obviously, you need to work a lot faster at the exam. That goes without saying. This point right here is going to end up being, let me just draw an arrow to it. It is going to be pi and 1. That is going to be that point. All right, so we have done everything we needed to do for this question. We have drawn it, we have labeled the intersection points, and we have labeled the end points. Hopefully you have found this helpful. Just before we end, let's look at our examination report, which is right here. And you can see, if I just make this nice and big, this is what we have drawn. You can see that 37% of the state got the full 2 marks. And let's just now read this little thing right here. Students who were successful with this question made a connection between part A. As I said, it's very important that you just don't start a question fresh. Knowing that you're starting a connection between part A is very important. Students who were successful with this question made a connection between part A and what was expected in part B. Most students were able to generate a horizontally reflected version of the given graph. However, some students dilated it or did not correctly reflect it in every section. Some students forgot the translation or did not label the points specified by the question. Students are advised to practice sketching graph with attention to curvature. How important is that? So they will deduct marks if your curvature is not correct. So what they mean by that is, do you see how it flattens out there and then rises? I've tried to replicate that there. And you know what? I haven't done a horrible job, but yours should look neater. Making sure it kind of flattens out at some places and just has a nice curvature is very important. Okay, so with that being said, we have covered everything you need to know for this question. Hopefully you have found this helpful. Let me leave that there. Not the prettiest thing in the world. Yours should be neater. That goes without saying. But I'm going to leave it there. I will see you in the next video.